Well, it's the last session of a very long day. I'm surprised to see so many people here, but I appreciate you coming out. It's my goal to put on a pretty good show here for you and make it worth your time. I'm sure there's some free beer somewhere. So, again, appreciate you coming out. My name's Neil Peterson. I'm a premier field engineer with Microsoft, and I live in Houston, Texas. So it's 3:30 a.m. where I come from. I've been having a great time here in Gold Coast, Australia. This has been a great event, so I'm glad to be here. What I'm prepared to talk to you about this evening is complex maintenance with Configuration Manager and Orchestrator. More specifically, I'm going to show you a live demo of deploying software updates to a Hyper-V cluster in a very graceful fashion using System Center Orchestrator 2012 as kind of the orchestration components. We're going to see integration between a bunch of different System Center components. So within this demo, we're going to see Operations Manager, Service Manager, Configuration Manager, Orchestrator, Hyper-V clusters. We'll see some PowerShell. So it's a big, huge kind of smorgasbord of capabilities when using Orchestrator and the System Center suite integrated together. So I guess before I get started, can I just get a show of hands of those of you who are already using Orchestrator, somewhat familiar with the capabilities of Orchestrator? So roughly, potentially half of the room. Anybody in the room, just first time you've ever even heard of Orchestrator? So I'm not, unfortunately, going to have time to kind of go into the fundamentals of Orchestrator. So that throughout this demo, there's going to be a little bit of a understanding that you've got some basic knowledge of Orchestrator. But even if this is the first time you've seen it, it'll be a great demonstration of the capabilities of Orchestrator. And I'll do my best as I walk through kind of some different run books to kind of call out exactly what it is we're doing. So the goals of this session is really to demonstrate that complex maintenance doesn't have to be a tedious, inefficient, and just, it doesn't have to be a pain. And by complex maintenance, I mean I've got these groups of 4 computers, and I need to maintain them monthly, but this one has to be rebooted before this one. And this one can't be rebooted until this one's back up. So, traditionally, this has been a very big pain point. Using technology such as Orchestrator, we can now get around this. I want to position Configuration Manager and Orchestrator as an ideal solution for complex maintenance. But to be fair, I'm going to talk about some other alternatives as well. And then finally, I'm going to provide an end-to-end sample solution. So I'm actually going to, like I said, I'm going to patch a Hyper-V cluster right in front of you in a very graceful manner without affecting the services being run on that cluster. I would like to point out this is just a sample kind of solution. This is not something that would just fit right into your environments. I mean, it's something that works well in my lab. If you're interested, the run books that I'm going to show are available for download. But again, they're more of kind of a sample, here's the capabilities, here's some kind of ideas to get you started. So I just wanted to get that out of the way. So we're going to talk about a couple different things. First of all, cluster maintenance. What is traditional cluster maintenance? What does it mean to maintain a cluster or apply updates to a cluster? Then we're going to look at the sample solution, which is basically just going to be a big demonstration. And then I'll talk about some of the challenges that I was faced when developing these run books and hit a little bit on some extensions that you could do or some capabilities that I haven't necessarily shown in the demonstration. So in interest of time, I'm just going to jump right in and talk about patching clusters. So I've been, let me start with a little bit about myself. I'm a premier field engineer supporting System Center Orchestrator. Up until just about a couple months ago, I have been supporting Configuration Manager and SMS for 10, 15 years. So I've been deploying software updates for a long time. I've been through all the trials and tribulations of deploying software updates, including having to deploy software updates to some clusters in the past. I ran into some situations in former jobs where it was determined that the clusters that we wanted to patch, a 2-node SQL cluster, was just too delicate to automate the deployment around. So I got the privilege of waking up every Saturday morning or once a month on Saturday morning and manually applying updates to this cluster just to make sure that everything went smoothly. And it was a pain. So what did that maintenance look like? What was I performing Saturday morning as I manually sat down at that cluster and deployed updates to the nodes that make up that cluster? So the first thing I needed to do was determine the cluster state. So I've got a name of a cluster, but what are the nodes that make up that cluster? Is it 2, is it 3, is it 8? So I've got to determine the cluster state, determine who's holding what role, just kind of get my head around, okay, here's the state my cluster's in before I attack it. I then had to log into node 1, pause it, drain the roles, kind of get everything off of node 1 so that it's ready for maintenance. Then I have to go out to Operations Manager and put that node into maintenance mode. The last thing I want to do is, email the SQL team on Saturday morning that one of their nodes just went down via an Operations Manager alert. I'd then launch Windows updates or whatever update method I'm using, I would have to manually kind of walk into that and start that update installation on that box. Start the update process. Then I'd have to wait for the updates to complete, which was just kind of a time-consuming, boring, twiddling my thumbs type of activity. Once the updates have been applied, I'd reboot the node, wait for the node to come back up, validate my updates have been installed successfully, validate that the cluster services have started successfully. The last thing I want to do is add this machine back to the cluster if something happened to the cluster services and Windows failover clustering isn't working on the box. I then want to remove the node from Operations Manager maintenance mode. And then I have to repeat this exercise for each node of that cluster. We can have really large clusters these days. This could be a very time-consuming manual process. Finally, rebalance the roles across the clusters, make sure that the cluster is in a state at which I can walk away, validate completion, validate functionality, and then close out change requests, send emails, let the SQL team know, hey, I'm just the patching guy, and your cluster is up to date. That is a serious pain, especially doing it manually. So, over the years, what are some traditional methods for cluster maintenance that I've seen? One, we just talked about, the manual maintenance. I see this quite often. And again, our clusters are just too sensitive to partake in your SCCM thing, so we're not going to do it. We're just going to manually do this. What a pain. Additionally, I've seen scenarios where an organization may choose to use complex configurations of configuration manager collections and maintenance windows. So again, assuming a little bit of comfort level with configuration manager, but I've seen customers or organizations that will create a collection with a maintenance window of 1 to 2 a.m., and then another collection with a maintenance window of 2 to 3 a.m., and then another collection with a maintenance window of 3 to 4 a.m., and then put a node of the cluster in each collection and try to kind of stagger updates that way. And I'll say in theory, okay, maybe, but that just doesn't sound very practical. It doesn't sound like it's going to give a very consistent and predictable experience each time. Thirdly, I've seen a lot of organizations use complex configurations of scripts, scheduled tasks, and other kind of homegrown, development efforts. And oftentimes these are really good. I mean, they work really well. They're awesome. However, they're unfortunately not very portable, not very supportable. You've got some engineer has written, a 32 or a 300-line PowerShell script to maintain the clusters, and then this guy gets hit by a bus. Who's going to pick up this patching mechanism and be able to run with it and maintain it and support it? So not devaluing these kind of homegrown solutions, but there's some limitations there. And then as a premier field engineer, I spend a lot of time with a lot of different organizations, and it's this fourth bullet point that, believe it or not, I see happening most, and that is, in a lot of cases, cluster systems are just excluded from the maintenance altogether. They're complex systems, they're sensitive systems, we can't risk taking them down, we don't know what to do with them yet, so we're just going to push them off to the side, and that's really scary. If you think about the types of data and the type of workloads that we're putting on clustered systems, it's usually pretty sensitive stuff. You know, we want high availability. This data or this application is so important to us that we can't risk it going down, therefore we're going to put it on a clustered system, but we don't know how to maintain it, so we're not going to do anything to it. Not a great situation. However, trust me, this is what I see most often out of all four of these. So the good news is it's 2013 and we've got options, right? We don't have to deal with this, with the heartache of manual maintenance or writing scripts or just not maintaining these machines anymore. In fact, we've got multiple options. And in fact, what I'm going to show you is kind of a homegrown option using System Center Orchestrator. Before getting into that, though, I want to plug two kind of out-of-the-box solutions that may actually be a better fit in some circumstances. And one is Windows 2012 cluster-aware updating. So if you're not aware of cluster-aware updating, it's a capability of Windows 2012 failover clustering to maintain Windows 2012 clusters in a very similar fashion to what I'm going to do today. So it's kind of a one-click, patch my clusters, move the roles, wait for one node to go down, wait for it to come back up before I move into the next node. So this is native to Windows 2012 failover clustering, and it exists just by installing a Windows 2012 failover cluster. So if you're patching Windows 2012 failover clusters, there may be a better option than what we're talking about today. Similarly, Virtual Machine Manager has its own capabilities of maintaining Hyper-V clusters. So inside of System Center Virtual Machine Manager is a cluster updating mechanism that integrates with WSUS to maintain those clusters. So if you've got Windows 2012 clusters, you've got cluster-aware updating. If you've got Hyper-V clusters, you've got Virtual Machine Manager. They are out-of-the-box solutions. They exist by installing the products. However, if you want more flexibility than what these offer, if you have Windows 2008 clusters that are not Hyper-V, there is no out-of-the-box solution. So there are still cases where an orchestrated scenario like we're going to see today is very beneficial. And if you want complete flexibility, orchestrated scenario is the way to go. Cluster-aware updating, I just talked about that, so I'm going to skip that slide. So patching clusters with System Center 2012 SP1. This is what we're here to talk about. This is what I'm going to show. So the sample solution that I'm going to show consists of the following components. Windows 2012 failover cluster, System Center 2012 Orchestrator SP1, System Center 2012 Configuration Manager SP1. I've got the System Center 2012 SP1 integration packs integrated into Orchestrator, Service Manager, and Operations Manager. So we're about to see kind of the whole shebang, total integration between many different System Center components. So what does this solution do? What automation does this Orchestrator runbook solution that we're about to see perform? Well, the first thing it's going to do is an update request goes in through Service Manager. So if you haven't seen Service Manager, if you haven't used Service Manager, you'll see it here. We're going to enter a service request through Service Manager to have a cluster updated. Service Manager will then initiate the System Center Orchestrator runbook, which will prepare Configuration Manager for updating of these clusters. The runbooks will then examine the cluster, determine what nodes are in the cluster, how many nodes are in the cluster, It will then place the first node in Operations Manager maintenance mode, pause the cluster node, drain the roles from the node, drop it in a Configuration Manager collection, refresh the policy on the machine. Configuration Manager will handle the updating of the system. We'll examine the node to determine if the updates are applicable, if they've installed, if a reboot's required. If a reboot's required, we'll reboot the machine. We'll wait for it to come back up. Once it's up, we'll join that node back to the cluster. We'll validate the cluster services are started, and then join it back to the cluster. We'll then resume the node, fail back all the roles that were on the node back to the node, repeat these steps for every node in the cluster. We'll then close the service request. We'll update it and close it. We'll then clean up the Configuration Manager environment. So I know this slide is very busy. I did that for a reason. This list looks very similar to that manual list we saw earlier. A bunch of steps, however, this time it's automated. So meanwhile, while this is going on, the patching administrator is playing golf or fishing or skydiving or whatever it is that the administrator wants to be doing at 2 a.m. on a Saturday morning during the maintenance window. So pretty handy stuff. So I'm going to jump into my demo, and this is going to be a very demo-driven session. What I think I'm going to do here, because we are going to be patching a cluster and it does take time, what I'm going to do is kind of walk through this runbook solution from just kind of an overview, walk through all the steps, execute it, let it kind of run through one of the cycles. I'm then going to jump back into my slides, talk about some of the challenges that I ran into when developing the runbook solution. Jump back into the demo. By that time, the patching process should have been completed. And then I'll deep dive into some of the kind of the more complex pieces of the runbook solution. Sound good? So really quickly, if this is your first time seeing Orchestrator, basically Orchestrator is an automation tool. Kind of drag and drop like. We've got what we call activities that perform certain features. And we can link activities together with links and perform a series of tasks. We've got a concept of integration packs, which adds activities for specific products, such as, you can see here, I've got activities for System Center products. So for Configuration Manager, add a collection rule, create a collection, delete a collection, etc. So within Orchestrator, we create runbooks that contain a string of activities that perform an action. We basically link activities, we link actions together, and then we build in some logic to make sure everything flows the way we want it to. So for this solution, I've got several different runbooks that perform the whole maintenance of my clusters. Kind of as a rule, I develop my runbooks to be very simple and small and modular-like. So instead of having one big runbook with 700 activities that kind of performs this big process, which you can do, I keep everything small and function-like. So if you've done any coding or any scripting, basically I create small functions that perform small actions, and then I link them together using what we refer to as an invoke runbook activity. So I basically call small functions at different places. For instance, here's a very small function. All it does is starts maintenance mode for whatever computer that we pass into that function. So I do this at several different times during this whole cluster patching experience. Instead of having that activity in multiple different places, I just refer back to this runbook whenever I need to place a machine into maintenance mode. So that's why you're going to see me kind of clicking back and forth between several different runbooks, because my runbook solution is a large group of small functions, if you will. I start everything from what I consider a main worker runbook. And what you can see here is that it's just calling a bunch of sub-runbooks, and then in some of those sub-runbooks, I call other sub-runbooks. So to start the process out, we pass in the cluster name, and we'll see this in action. So what we'll see is that when we enter the service request, our service request form in Service Manager takes in one piece of data, and that's the name of the cluster. That name is then passed into this runbook solution. And the first thing that we do is prepare Configuration Manager. So my first runbook activity, or my first invoke runbook activity, actually calls this configure updates runbook, which creates a collection in Configuration Manager. So at this point, we're just preparing Configuration Manager to do its job, which is to apply updates to the cluster. So we create a collection. We then deploy software updates to that collection. So in Configuration Manager, we've already got an update group prepared to go. We're basically just deploying that update group to the collection that we just created. I then just use a little PowerShell to get the deployment ID of that deployment. So we've just created the deployment of updates and deployed it to the collection. I want to take that deployment ID because I'm going to use it later on for something which I'll show you. I then return that deployment ID back up to my main worker runbook so that I have it on my orchestrator data bus for later use. So at this point, we've prepared Configuration Manager. We have a collection with software updates deployed to it. We start dropping computers into that collection, they're going to start getting updates. The next thing I do is detect the cluster state of my cluster. So clusters are dynamic beings. You know, I could have written this to take in a comma delimited string of cluster nodes and then parse that out and then perform the actions on each node. But what happens if 2 months later somebody adds a third node to the cluster or removes a node from the cluster? I want to make sure that I'm targeting the full cluster every time I run this process. So I've just got a piece of PowerShell script, and I'm not going to dig too deep into some of this first pass around. When I come back around, we'll look at some of the intricate pieces here. But basically, I'm just running a piece of PowerShell script to get cluster node, space dash cluster, and then the name of the cluster. So I'm just basically using a PowerShell commandlet to echo back all the nodes in that cluster, put them on my orchestrator data bus for use later on downstream. I'm then, one at a time, going to start piping each node of those clusters into my next runbook, which is basically where most of the work happens, which is the apply updates runbook. The first thing I'm going to do is take that first cluster node, pipe it into this Start Operations Manager Maintenance Mode runbook, which will come over here. Very simple little activity, straight out of the box. Just puts a machine in the Operations Manager Maintenance Mode. That's it. Once that's completed, we come back in. Then I'm going to suspend that cluster node. So I've got Configuration Manager prepared. I know the node I'm about to maintain. I've put it in Operations Manager Maintenance Mode. I'm not going to be firing off emails that it's being rebooted and whatnot. Now I need to evacuate all my roles from it. For this, I'm using PowerShell. We'll talk about this again in depth, but just a very simple PowerShell script or PowerShell commandlet to suspend cluster node, space dash cluster, the cluster name, and then the name of the node. That's going to basically pause the node, remove all the roles off of it. So at this point, my machine's in maintenance mode in Operations Manager. It's also been evacuated of all the roles that are on it. So all my virtual machines or my SQL workloads or whatever I'm hosting on that cluster has been moved off somewhere else. My services are still up. My node is just a computer at this point. It's ready to be maintained. I'm then going to add that to the Configuration Manager collection that we just created. And then if you're not familiar with Configuration Manager, how the Configuration Manager client works is by default, every 60 minutes, that client reaches out to Configuration Manager and looks for, basically says, hey, is there anything new for me? Like, hey, you put me in a collection which has updates deployed to it, so cool, I'm going to install those updates now. But we don't want to wait 60 minutes. We're automating stuff here. So I've got another activity that just reaches out and tickles that machine and says, hey, go check for policies now because I just put you in a collection that has updates targeted at it. So instead of waiting 60 minutes, I want you to go ahead and find out that those exist now. Then comes kind of probably what was the most tricky part of this solution. I'm going to glaze through it right now and then come back to it because I want to get the demo started because like I said, we really are going to live patch a Hyper-V cluster here and it takes some time. But that was, at a high level, once the machines received policy from Configuration Manager and once it started its process, how do I know, well, A, how do I know that it started the process? And B, how do I know where it's at? Is it installing updates? Is it downloading updates? Are they already downloaded? Was there a failure? You know, I need to kind of somehow determine what's going on and not just rely on faith or not just put like a 5-minute wait in there. Like, okay, you know, I know it kind of takes about 5 minutes for 3 updates to come down, so I'm just going to pause right here. I needed to programmatically be able to determine that A, the computer's received updates, and B, it's finished installing updates, and actually C, determine whether or not it needs a reboot. At that point, I then branch either one of 2 ways. If it requires a reboot, I'm going to restart the system, wait for the system to go down, wait for the system to come back up. If it doesn't require a reboot, I'm going to skip all of that. And then finally, with updating completed, I'm going to resume the cluster node, basically the opposite of suspending it. And I've just got a simple little PowerShell script that resumes the node. Resume cluster node, space, dash, name of the cluster, and then the node. You'll notice I also am checking the cluster service here. So basically, just because the machines come back up doesn't mean all the services are lit up. So I want to make sure my cluster service is up and running before I add those roles back to it. So there's just a little bit of kind of good housekeeping in there. This is probably a good time to point out one thing that you're not seeing here is any error control or logging in this runbook solution. I've left that out intentionally, really just for the ease of demonstration. When you add error control and logging to any runbook, you're going to add a lot of activities to your runbook designer, and it makes it a little more difficult to walk through in a kind of a scenario like this. But in any kind of production solution like this, you would want to add some error control. So for instance, right here, I've got an activity checking for the cluster service, and I'm looping on this activity, waiting for that cluster service to come up. Once I can prove that the cluster service is running, I'm going to then fail my roles back. You may want to do something here, and this is very simple to do in Orchestrator, such as if that cluster service doesn't come up in 20 minutes, you know, run some sort of error routine. Send an email or update the service manager ticket or whatever it is you want to do. But you're going to want to have error control in your solution. I've just left it out for ease of demonstration. All right, so we've patched one node. We've resumed the cluster node. Finally, we're going to pull it out of Operations Manager maintenance mode. Come back from our git cluster PowerShell command. We're going to take and pipe in the next node, and we're going to do this for every node of the cluster. So if we got a 16-node cluster, this process will run 16 times. Once we're completed, we pop back up to the main worker runbook. We're then going to clean everything up, which is pretty simple. This is just a demonstration here. Basically, all I'm doing is deleting the collection in Configuration Manager, which also deletes the software updates deployment as well. And then the last thing is, because we're using Service Manager here, because I've started this process by submitting a Service Manager service request, I'm going to go back in and close the request. So really kind of bring this thing, you know, full circle. And that would end the execution here. So let's go ahead and get this thing started. So what we've got here is the System Center Service Manager self-service portal. I've got several service offerings here. I'm going to go into cluster maintenance. And these boxes are actually in a bedroom in Houston, Texas. All right, and so my request offering, patch cluster. I'm just going to go ahead and kick off this bad boy right here. to HVCLX. And I'm going to submit it. Now this does take a couple minutes to kind of come through into Orchestrator. So while it runs, I'm going to just kind of show you some of the pieces that we're going to be looking at. And I'm going to be jumping around between a bunch of different computers, watching all these components, kind of run. Obviously, in a production scenario, like I showed on my slides, we'd be out playing golf. We wouldn't be watching this. It all happens behind the scenes, but it wouldn't be fun for me to just stand up here and tell you that it's working. So we'll look at it. So what I've got is a 2-node cluster, a 2-node Hyper-V cluster. I've got several virtual machines. You can see here that they're spread across the 2 nodes pretty evenly. So 2 HVCLX1 and 2, and you can see the owner node, it's spread pretty evenly. No recent cluster events, so the cluster is fairly healthy, looks good. In Configuration Manager, under Device Collections, once this process kicks off, we'll be creating a collection right here. I just configured the runbook to name the collection the same name as the cluster. You can configure it however you would like in your own environment. So ultimately, we'll see a collection here with software updates deployed to it. And then in an automated fashion, we'll be adding each node of the cluster to that collection. Operations Manager, here's my 2 cluster nodes right here. We can see that neither of them are in maintenance mode right now. If we catch it, we'll be able to see both of those go in and out of maintenance mode. And then Service Manager, there's not a whole lot to see here. But our service request number is 1425. And there it is right there. So we've got an open service request while this process kicks off. So let's jump back into Orchestrator and see if we've given it enough time, and it is running. So we can see right here, we got this little green arrow. We know that it's running. And in fact, it's running fast. So we've already prepared Configuration Manager. So I'm going to jump in here and refresh my device collections node, if you will. And you can see here now we've got the collection that has the same name of the cluster. Look at the properties of this collection. Got no members yet. However, we can see that we've got some updates deployed to it. So we got 4 updates. I kept it small just to try to keep this demo small. If you had 60 updates that you were deploying, as long as they're in that update group that we specify in the activity, they're going to be here. So Configuration Manager is prepared. I'm assuming we've already detected our cluster. All right, so Operations Manager. So real quick before I do that, well, I'm just going to jump in there. In Operations Manager, I'm going to refresh this. All right, so we can see that my node 1 is in Operations Manager maintenance mode. And we can see that it's being suspended as well, which hasn't started. So that's great. So if you look right up here, in just a moment, assuming everything works, it should suspend itself, which it just did. And now we can see the virtual machines being live migrated off of that node and onto the second node. Give that a second to complete. And again, we're kind of following along. Wouldn't do this in a real life scenario. And while that completes, just to show you a little more of what I've done there, not only have I just triggered the action to suspend the cluster node, but I want to check my work here. So just because I've kicked off a command to suspend the cluster node, I then followed it up with another command, another PowerShell script, basically just to reach out to that node and get the number of roles currently on it. And I'm going to loop on this activity until that number equals 0. So I've kicked off a drain on the cluster node, but if I've got 700 roles on that cluster node, it's going to take a really long time to drain. I don't want to actually move on until the drain is completed. So not only am I simply kicking off a drain, I'm then following it up with kind of a check and balance to make sure that the drain is successful. So that kind of keeps us encapsulated in this runbook right here until a time at which that cluster is completely empty, and then we'll move on. And so at this point, we can see that cluster node 1 is paused. All of my virtual machines have been migrated to cluster node 2. It's in operations manager maintenance mode. So, at this point, it's fair game for patching. So if we come back into Orchestrator, we can see that we've just run the activity to add collection rule. So again, if you're not familiar with Orchestrator, what we're looking at here is just the log window down here on the bottom piece. It basically just shows you the status of the execution of your runbook. So for each one of these activities, I can see the corresponding log, and I can see right here that my add collection rule has completed successfully. So if we come over into Configuration Manager and refresh device collections, we can see here that our collection now has a member count of 1, just for fun. And because we have a little bit of time, I will show you here that that member is actually the first node of the cluster. So proper node is in the collection. Come back in here and refresh this bad boy and see where we're at. All right, so once we added the machine to the collection, we refreshed the policy on the machine. We then ran a little bit of WMI magic to make sure that policy's been successfully applied. I'll show you that in a minute. We're then monitoring for the update installation. We then trigger the restart on the system, and we're waiting for the restart. I don't know if you just caught it, but we can see up here that that machine actually was just rebooted. So now we're kind of in a holding pattern, waiting for that computer to come back up. And again, I elected to write all this stuff into my runbook. While we wait for that to come back up, my first iteration, or one of my first iterations of this runbook solution, I allowed Configuration Manager to handle the reboots. So I didn't have any of this logic looking for reboots or determining if a reboot was needed. I just allowed Configuration Manager to handle it. The issue I ran into is ultimately 1 month updates were released that didn't require a reboot. And I had no logic in my runbook to handle that. So my runbook just sat there waiting for the computer to reboot, and it never rebooted because reboots weren't required. So I had to actually build that logic into the runbook solution, hence why I'm handling the reboot here and not out of Configuration Manager. That question comes up quite often, so that's the explanation there. Machine should be back up by now. Yep, and we can see it's back up. And we can see that our resume cluster node job has triggered. And we can see the node has been unpaused, and the virtual machines are being live migrated back to node 1. And additionally, that it is out of maintenance mode. Once those machines have been completely live migrated back over, we'll then start the process over again for the second node in the cluster and third and fourth, given more nodes than 2. We'll then come back and clean up Configuration Manager and close out the service request. So rather than sit here and watch that happen again for the next node, I'm going to jump back into the slides and talk about some of the challenges and lessons learned that I encountered when developing this runbook solution. And quite honestly, what we're doing, we're looking at patching clusters here. But, I mean, this is really just a good demonstration of the capabilities of Orchestrator and a good discussion around some of the thought that you want to put into developing complex runbook solutions, such as stuff that I already talked about, like error control, having that error control in there. Just because we didn't see any error control here doesn't mean it shouldn't be there. I just omitted it for demonstration purposes. Or stuff like, I've rebooted a computer, now I want to do stuff to a computer. Well, just because the computer's been rebooted, we may want to go check our relevant services before we do anything. So again, while we're talking about patching clusters, I mean, a lot of this is very general, kind of Orchestrator lessons learned, if you will, or runbook design lesson learned, including some of the details I'm about to discuss. So kind of 4 big challenges I had with this runbook solution. And the first was that there's no native integration pack for failover clusters. So earlier on, we kind of took a real quick minute tour of Orchestrator and the runbook designer, and I showed you the integration packs for System-Centered Configuration Manager. So an integration pack gives us this real drag and drop experience where, if there were an integration pack for failover clusters, I would have just been able to drag an activity over and given it a clustered node name, and it would have failed the rolls over. But that integration pack doesn't exist. So, and this is a very common scenario. There are not integration packs for everything that we want to automate using Orchestrator. Fortunately, we've got activities such as the run.NET script activity, which we can plug PowerShell into, or the query WMI activity, or the query database activity, which are very generalized activities that allow us to kind of, get out of the box of kind of the drag and drop experience. So in this case, without an integration pack for Windows failover clustering, I just simply relied on PowerShell. I've heard it said a couple times that Orchestrator, it's drag and drop and no coding necessary. And I say not quite. You can get to about 85% of the way, but ultimately a little bit of PowerShell is going to be pretty beneficial, as it was in this case. So we'll look a little bit at that. We'll look at the PowerShell a little bit deeper and kind of some of the challenges around PowerShell in your Orchestrator runbook solutions. The second issue I ran into is common to all runbook development, and that is the multi-value data handling. So when I ran the script to get the cluster nodes, I've got a 2-node cluster. It returns a collection or an array of data. Whenever you get an array of data flowing across an Orchestrator runbook data bus, you've got what we consider multi-value data. If I've got 2 pieces of data that come out of a script or any activity that creates multi-value data, every activity after that activity happens for as many times as data that you have in that array. So for instance, if I was to run a script that determined every file at the root of C and then send an email when it's done, if there's 30 files at the root of C, I would send 30 emails. So you've got a part of runbook design, kind of one of the first challenges that you get over when learning to write Orchestrator runbooks is how to handle multi-value data, because it happens. It happens all the time. And I ran into the challenge here. Some of my first iterations, I was like, all right, I feel good about this. I'm going to go, bam. And I ended up patching every node of the cluster at the same time. So I had to make special considerations. I've got these nodes of clusters running down this data stream, if you will. How do I kind of like isolate it so that I'm, gracefully handling this? Then I was like, well, man, maybe if I've got a 4-node cluster, can I get it so I can patch 3 nodes and then come back in and patch the last node? And ultimately what I arrived at is that I wanted to patch 1 node at a time, and I just needed to somehow shim out that data. So I'm affecting 1 node at a time. And I'll show you how I did it here. There's tons of different ways you can handle multi-value data. If you're just dipping your toes into Orchestrator runbook design, this is going to happen. You're going to have something, you're going to hit go, and it's like, oh man, why did that happen 40 times? It should have only happened once. It's like, you've generated multi-value data somewhere. And then third and fourth really kind of tied together, and they're very configuration manager specific, and they were the biggest challenges I had here, and that was how to detect when when the policies arrived. So we put the computer in the collection and we refreshed the policy, but anybody in the room that's used configuration manager at any kind of depth, I'm sure you're aware that configuration manager kind of has a mind of its own in some cases. So we really, really want to be sure that that machine received policy. Not only do we want to be sure that it received policy, but I want to make sure that it received the policy that has the software updates in it, and not just some other random policy. My timing was weird or something. So how do I determine that? And then finally, how do I appropriately handle if a machine doesn't need a reboot, or if it does need a reboot? How do I nail this so that I know when the machine's completed running its software updates, and then whether or not it needs a reboot? So these are kind of the four big challenges I ran into. Honestly, the rest of this stuff was just drag and drop, kind of setting up my link logic. It was pretty simple stuff. So challenge one, the PowerShell script. So kind of layering on the mystery of PowerShell and Orchestrator runbooks. There's a well-known limitation, if you will, that Orchestrator, or more specifically the run.net script activity in Orchestrator, enumerates a PowerShell session that's running in a 32-bit run space. So basically, 32-bit PowerShell. However, the Git cluster node and the other Windows failover cluster commandlets are 64-bit. So not only did I have the challenge of I don't have a failover cluster integration pack or activities, now I have a second challenge of Orchestrator by default doesn't run 64-bit commandlets very well. So I had to get around that. And it's actually not that difficult. What you can see here is I've got, basically what I'm doing is calling a second instance of PowerShell, which is my 64-bit version of PowerShell. And I've got encapsulated in these squiggly lines my code. So basically just a very easy workaround to execute 64-bit, execute PowerShell in a 64-bit run space from within a run.net script activity. I'll go ahead and plug a couple blogs right now. If you are doing any PowerShell work within Orchestrator, you're going to run into this. I mean, it's going to happen, and there's other limitations. For instance, if we wanted to pull data, so if I was adding data to a variable here, well, this commandlet's encapsulated in a separate execution of PowerShell. It's not as simple as, it's difficult to pull that data back out. So not specific to this solution because I'm not pulling data back, but bottom line is if you're going to be doing any PowerShell work in Orchestrator, or more specifically the run.net script activity, there's a gentleman named Carl Prosser, Prosser, and he's a PowerShell guy. I've never met him, but he's a PowerShell guy that dabbled a little bit in Orchestrator and kind of really quickly ran across all these limitations and blogged a bunch of different solutions for him. And basically everything you need to do anything you need to do in the run.net script activity is documented pretty well on his blog. So that's how I got around challenge one. Challenge two, the multi-value data handling, was very simple in this case, actually. Really, what I had was, so I get my cluster nodes, and then I feed them into an invoke runbook activity, which is then the application of updates to each of those nodes. Well, on my invoke runbook activities, there's a checkbox right here titled wait for completion. And basically what happens is the first node goes in, it executes that big series of activities, patches the node, and my second node doesn't go in until that first run has completed. So in this case, the solution was very easy, wait for completion. And actually, I arranged this. You'll notice that this runbook right here is pretty dinky. It doesn't do a whole lot. It's like, man, why did I have this apply updates here and not up in the main worker runbook? It just made sense in this case, or this configuration really massaged or helped with that multi-value data in a very graceful way. Third and fourth, I think I'm just going to dig into those in the demo. But basically, the answer is that the System Center Configuration Manager 2012 client has some additional WMI namespaces that really gave me all the information I needed to find about the installation of the updates. You know, has the policy arrived? What's the state of the updates? In fact, right here, the namespace is CCM Client SDK, and here's the class, CCM Software Updates. You can see here I've got a list of values, which, and this may not be that visible out there, but the slide deck's available. This is straight from the SDK. Basically, I get a list of values of what's happening at the time I query that namespace. So downloading updates, installing updates, requires reboot, completed. So it is basically spelled out for me. I just had to snoop around in WMI and figure it out. So with that said, let's jump back into the demo, see where we're at. First, let's make sure that our execution's completed. What I can see here is that my node 2 has been rebooted, so I can connect back to it. Back in Orchestrator, I'll just kind of go back up to my main worker runbook. I can see that this is totally completed. I'll just snoop around a little bit, like clean up. All right, I can see that runbook was completed. Update and close SR to close out their service request. I can see that's been completed. So let's just snoop around on node 1, node 2. All right, I can see both my nodes are up. I can see my roles are pretty evenly distributed. I can tell you right now they're right where they were before we started the whole process. If I go into Operations Manager, Operations Manager, I can see that neither of the nodes are in maintenance mode. Go into Configuration Manager, here's the collection, but if I refresh this screen here, I can see the collection's gone. So everything's been completed. So basically, my nodes have been updated, and it's like we weren't even here. And you can see during that second wave, or that second node, I was up here talking, we weren't doing anything. So everything was automated in the background. So I think that's pretty cool. So as promised, though, I'm going to look at some of these kind of limitations or some of these issues that I ran into and just examine them at a greater depth. So get cluster nodes. So no activity exists, and we pretty much already saw this, but basically I've got a PowerShell script, and I've got it encapsulated in this code that calls a second PowerShell script. You actually want to see what happens if we don't do that? This is pretty cool. So I'm going to take this out of here. Get cluster node space dash cluster. Create a new runbook. I don't usually deviate from my script, but I think this is worth it. So I've got a run.NET script activity here. I'm going to specify a type of PowerShell. Drop my commandlet in there. I'm just going to hard code in here. Run my runbook tester. So now we know that that's a valid we know that's a valid PowerShell commandlet. It just so happens that it's a 64-bit PowerShell commandlet, and we've enumerated a 32-bit. We've created a PowerShell session running in a 32-bit run space. So if we look in here, what we're going to see, the error that we've returned is the term get cluster node is not recognized as the name of a commandlet or function. So if you're running PowerShell in the run.NET Script activity and you run into this, red flag, you've got a non-supported commandlet, you're going to need to use some of the workarounds that can be found in the blog that we talked about. All right, so that said, let's jump back into our runbooks. And the second issue, which we've pretty much already seen, was the multi-value data. Again, out of this activity, I'm publishing multiple pieces of data. On my apply updates invoke runbook activity, if I was to uncheck this wait for completion, I would patch, it would work. I would just end up patching every node of the cluster at the same time. In other words, I could have concurrent executions of this runbook running in parallel, which was not what I wanted. So very simple little solution there. Third and fourth is the how to check for policy. So recall back early on when we were preparing Configuration Manager, I created a collection, I deployed software updates to that collection, and then I ran a PowerShell script. And don't let the lines of code here scare you off. It's really just a very little piece of code that I'm worried about here. Get CM deployment space dash collection name, and then the name of the collection that we just created, and then I'm putting into a variable the deployment ID of the deployment targeted at that collection. So basically, we created a deployment, and I'm stuffing that deployment ID into a variable, putting it on the data bus, and returning that up to my main worker runbook. I then pass that around, and at the point I get to the application of software updates, once I've added the machine to the collection and refreshed the policy on the machine, I determine that I can then snoop around in WMI, basically the namespace of root.ccm software updates deployment agent, and you can see my WMI query here, select star from CCM underscore target update EX1 where referent assignment ID like, and then right here, I'm not going to scroll over because I don't want to mess with zoom it, I have the published data that is the deployment ID that we pulled from several runbooks back. So basically, this WMI query is returning, hey, yeah, I see it. I see the policy that contains the deployments that are deployed at that collection. So you got it. You are going to be installing these updates. We're good to go. And now let's monitor the installation of those updates, which is another WMI query. Namespace root CCM client SDK. WMI query is select evaluation state from CCM software update. Now this kicks back all kinds of values. If you remember back in my slide, I had a big long list of potential values. Basically all I've done is sorted those out, and I'm looping on this activity until I reach some very specific values that indicate whether or not the software update installation has been completed. So if you're interested in this, I'm not going to deep dive into all these values. If you are interested in this and this is something that you want to take a closer look at, this runbook is available for download. I don't think I put the reference in my slide, but I'll talk about it once we end this session. So that was really the big challenges. The rest of it was pretty simple stuff. To achieve, kind of this very flexible, actually totally flexible software update solution for a cluster. So I've got a couple more slides, and I'm going to end with a couple, a very small demo. But basically, so that was cool. we've seen how to deploy updates to a cluster using Orchestrator. Again, I want to reiterate there may be better solutions, virtual machine manager, cluster-aware updating, but there are a lot of cases where Orchestrator is the best solution. One of those being if you've got 2008 clusters that are non-Hyper-V. There is no Microsoft product that's going to take care of that for you. And then there's some edge cases. You may have a Hyper-V 2012 cluster, but you just want to build your own tight solution that has complete flexibility, and maybe you want to extend onto that in other ways. Well, that's the cool thing about Orchestrator. I mean, it's bee's knees. You can do pretty much whatever you want to do with it, given the development knowledge. So what are some of the things you can do? So real-time reporting. I don't have it incorporated in here, but after each one of those activities, we could have easily dropped a query SQL database activity. And every time we did anything, we could insert a line into a database. And then somewhere else, we could pick that up and see in real time the deployment of our updates if we cared about it. Or we could stuff them all in that database and not report on it in real time, but at the very end of the runbook solution, query that database and put all that data in an email. And then I could receive an email on my phone out at the golf course that shows, oh, cool, not only are my clusters updated, but I can see timestamps of when every activity happened. Like, oh, I can see node 1 went down at this time, and then it came up 5 minutes later. This is very easy stuff to do. I've done it. I mean, given an hour, we could stand here and do it right now. This is not trivial stuff to do. Enhanced service manager integration. So I'm going to show you just kind of a little cheesy piece of that here, but we can do a lot layering service manager into this. I mean, build this process right into your change control process through the incorporations of service manager, or take that SQL query of that data that we stuffed in a database and then write that to the service request. So we've got a permanent record of this update run. Very, very simple stuff to do. Email notifications, and then basically, be creative. You can pretty much do whatever you want to do with this stuff. So a very, very cheesy little demo here. And actually, there's no demo to it. It's already done. But as an example, one of the things that I built into this runbook solution just to demonstrate kind of taking it further is not only did I come in and close out the service request, but I threw in a simple little cheesy activity to update the service request with some information about the deployment. So if I go look at my service manager service request, we've actually got data in here. So I basically updated the description field of the service manager service request with 2 timestamps. So cluster maintenance started at, and I need to format that time, but basically 8:58. Cluster maintenance completed at 9:13. So, kind of just taking it a little further. I mean, we've got integration here. We've got automation. We might as well put some data back, provide some data about this update run because we have access to it. So pretty cheesy little demo. If you want to see some other stuff, I've got some blogs where I actually show the real-time reporting or pulling of the data, stuffing it into an email in a table, a well-formatted email. So that is my session. I've got several minutes available for question and answer. Let me go ahead and plug my blog. Here's a couple sessions kind of related to Orchestrator. I didn't throw it on my slides, but these runbooks are available for download at my blog, which is blogs.technet.com/Neil P, Neilp, as well as, if you want to see kind of the real-time reporting, I've got a blog with a video that basically, it's an older version of the runbook, but it shows some real-time reporting, some stuffing of the data in a SQL database, pulling that out at the end of the update run, and sending an email with a table of all the steps in the run. So quite a bit of kind of cool little add-on features, if you will, to what we've just seen. So that's it. Thanks for coming out.